Hello everyone, I'm Alexandre Chapo and I will be your host for today's webinar. On behalf of Furukawa, we welcome you to the webinar FTTH Network Solution on Demand, Concept and Project. The fast growth of FTTH demands new technologies to allow us to deliver a high-quality experience for customers with an optimized cost of implementation. On this webinar, we will present you our EasyStar solution, a pre-terminated technology that enables a pay-as-you-grow approach to optimize resources and allow growth with less investment. I present you my colleague Leandro Chalarca, who is a telecommunications engineer with more than 12 years of experience in fixed access network solutions for service providers. Specialized in sales, engineering, design, operation, and maintenance of FTTH and HFC networks. During the presentation, please feel free to ask questions in the comments section. We will address them at the end of the presentation. If you would like to schedule a meeting with Furukawa to learn more about our solutions or talk about any of your projects, you can click in the button, schedule a meeting, and we'll get in touch with you. Leandro, please take over.
Thank you very much. Hello, everyone. Thank you very much, Alexander, for the introduction. And thanks to those who attended this webinar for the time. I'm really very pleased to be here with you, sharing this small space. I would like to start with a little introduction about Furukawa. Furukawa is a Japanese company and has around 50,000 employees around the world and more than billions of dollars in revenues. 120 subsidiaries on the 5 continents, and we have a complete portfolio for telecommunication solutions. We have FCS, Furukawa Connectivity System, is a portfolio for structured cabling, category 5E, 6, 6A, PON solution. Also, we have FIS, Furukawa Industrial Solution System, is a portfolio dedicated for structured cabling about industrial segments. And finally, FBS, Furukawa Broadband System, is a portfolio oriented to outside plant FTTX solutions. So let's remember some context about FTTH PON networks. So PON networks are solutions. It's a passive network point-to-multipoint network that is no power supply is required at the external plant. They are made of 3 functional blocks: OLT, ODN, ONU, ONT. The OLT is the main aggregator equipment which is installed inside the central office or data center. The ODN is the passive optical networks. It's composed of splitters, optical cables, splice box, and NAP. NAP is network access point. And finally, the ONT, the optical network terminal, or ONU, optical network unit, it's a terminal equipment that is installed inside the subscriber's home. So here, we can see in this graph the principal points of the solution. Remember that we can here have different communication protocols, like, for example, GPON, EPON, XGS GPON, 10G EPON, and whatever, okay? So here is the ways of the evolution. Really, different ways of the evolution have stakes to build FTTX network. Remember that initially in the, for example, like year 2005, 2006, initially function networks were deployed. Subsequently, it involved a connector site network, which is mechanical connector is used in the subscriber connection because that lowest savings in deployment times cost. Also, I would like to comment that most of the operators are here right now. And finally, in the final of the evolution line is the pre-connect networks because it were deployed and offer a greater reliability and more savings time and cost. Here, the pre-connector site network is the new way of the solution and is the a solution that allow us to get many improvements of the network. Okay. Here is the a typical FTTH network. In this graph, we can see a typical diagram of connectorized FTTH network. In general, each port of the OLT is connected to the feeder network to a first level 1x8 optical splitter by fusing in the input and the outputs, and which installed inside the splicing box here. Subsequently, the outputs of these splitters are connected to the distribution network towards NAP. This is the NAP, network access point. You only can do here one splice at the enter of the splitters. This is the second level. And here we have the output, but the output is connectorized from the manufacturer in this case, okay? At the final part of the network, we have the drop cable, and the drop cable we don't have any splice. We only have a drop cable, and you can put mechanical connectors in both ends of the cable, okay? Here we can see detail about the drop network. As I mentioned earlier, connectorized systems are mainly characterized by installing mechanical connectors on the drop cable. In this case, Furukawa, this solution is known as easy access solution, okay? So we have the NAP, the cable, two mechanical connectors. One mechanical is gonna be installed inside the NAP, and the second connector is gonna be installed inside the rosette. After that, we have a patch cord that connected to the ONT, okay? So, but when you deploy networks in these systems, you have many challenges for the optical networks. We're gonna see some details of this part. One of the main challenges what's the main question is how to increase the efficiency and the quality of the networks, but at the same time maintain a lower or project cost. Out of this equation is some difficult. Furukawa developed a set of products and solutions that aim at this goal. Other greedy challenges is like, for example, demand is internally and ROI, return on investment. Simple construction with the least amount of specialized labor. Economy maintains and reliability of the network. Other point is for the financial part. To respond this challenge, the capex of the FTTS project was moved. Principally, in this study, we found that the 25% of the investment is related to the active equipment, and the other 75% of the capex is related with the ODN, like investment in passive equipment like splitters, optical cables, engineering service, and of course the labor cost. The labor is the heaviest part of the capex. So in this case, for example, many clients are only concerned with obtaining discounts for the purchase of materials or equipment, but in reality, the labor is the part that is the most important for this model, because it is about 50% of the cost of all over the project. So the question is here, how to reduce the network costs? How to reduce the CapEx and the OpEx is a big question. Of course, how to improve the payback and the cash flow. And other points here we can see is the workflow. The workforce becomes the point of the discussion to achieve the efficiency in operation and maintenance, training, and installation time. For example, in the operation and the maintenance, the question is, how long do you have to repair, for example, to fix the network, to repair the network? Is the repair complex or simple? What about the cost of the maintain the network? So I think that is the operational maintenance, the training, the installation time are part of the labor cost that is very influential for having some problems in the future. Thinking about these big challenges, Furukawa developed the Easy Start Preconnect solution. In this solution, characterized by allowing building and investment on demand and reducing the initial of the capex. The solution allows you uh, to do the investment in the pay-as-you-grow concept. You're only gonna be to invest in demand. You're gonna be only to invest in the NAPs on the distribution network only in the moment that we need. In next slide, we're gonna start. We're gonna detail more points that. Also, the solution allow you to have modularity, flexibility, agility, security, and economy. This is the topology, the typical topology of sister solution. From a topology view, is very similar to a traditional connector site network, the traditional network, where we have two levels of splitter 1/8. The difference is only especially in the distribution network. Because in the distribution network, we don't have any splice. It's all pre-connect solution. It's like a external optical patch curve in this part. The feeder network is exactly the same, but the difference is that the first level of a splitter here, we only have to do one splice at the input, so the output is pre-connected to the distribution network that is all pre-con. Okay, we don't have any splice here in the second part of the network. To the customer part, to the drop network, we only have here a drop cable, but is in this part we have a pre-connectory side drop cable that you're gonna connect to the NAP, and the other part you only have here a mechanical connector for connecting to the rosette or the ONT. Here we can see more details. So what's the idea? The idea is that the feeder network is the same. As I mentioned, the feeder network has major change. An optical cable, for example, I don't know, active fibers cones, go out from the central office until it reaches a distribution network where the connectorized 1/8 splitter is installed. That's only that we only have here one splice at the entrance of the splitter. In reality, the main change is in distribution network because here you're gonna be got out with 8 distribution cables, but the difference is that this monofiber cable, for example, one ADDS cable for illuminating the first NAP, and then you have another cable for connecting the second NAP. Inside the NAPs, you have a second level splitter 1/8, but the difference here is that the NAP is all sealed. You cannot open the box. The idea is avoid the technicians do some mistakes. So if you have eight NAPs, you have to go out with 8 different SDDS cables. For the distribution network, you have the ADDS cable. It's a compact cable, about 3 millimeters of diameter. And for the drop network, you have also a pre-connectory side network here. You have pre-connect drop cable, drop figure 8 drop friction cable, but it's only pre-connect in one end. It's different here in the distribution network because we have pre-connect the cable in both ends. Okay, it's like here like a patch cord for the outside line. So in this case, for example, is there another important point is a highlight of the solution about the pay-as-you-grow concept. How does it function? As I mentioned it in the previous slides, it's only necessary to install the backbone cable or the feeder cable and the main distribution box. So in the first moment in the project, the initial moment, you only have to buy and install the backbone cable or the feeder cable and also the distribution box. It's only your initial capex for the deployment. Only when there is a demand from a specific user inside this area, only this moment you're gonna have to install a new NAP with the respective cable. When you have this connected user, but for example, you have another user to connect, but is so far of this area, in this moment you can connect another NAP and install another distribution cable for connecting this new user, because this user is too far from this area. So in this moment, you only have two boxes, two NAPs. But in the future, you have another user that is too far from this box or too far from this box. In this moment, you can connect again another boxes, another cables, another distribution cables for connecting more and more users. So the idea is connecting users, connecting NAPs, connecting cables only when the demand is necessary, only in this moment. Another important point is that solution, you can install the boxes in the aerial solution and also in underground solution, because the boxes in this case are protected even with IP68 protection. So you can install in aerial environment or in underground environment. This is a comparative solution with the traditional easy access of connectorized solution versus FTTH Preconis Star solution. When you have a traditional network, it's like this part in this area. From the initial moment, you have to do all the investment, installing all the feeder network, all the boxes from the feeder network and distribution network. You have to buy all the NAPs, all the distribution network, all the splices. And additional, you have to do at least 17 fusion splices for each 64 users in the old supply network. So the capex is total from the first month. It's so different when you compare with FTTH Precon solution is Star, because in this case, the investment is on demand. The difference here is that in this case, you only have to invest in the feeder network and the principal box, the main box. So only when you have demand users for connecting, only in this moment you're gonna install another one NAP and the distribution cable. You can have some zones with no NAPs because you don't have demand, but you only have, you can have again other zones that maybe you have to install 1, 2, 3, or up to 8 NAP or distribution cable for connecting all users at this zone. Another difference is that you only have here one splice for each 64 users in the hot supply. So the idea with the EasyStar solution is that you can do more with less. It's the perfect solution for improvement of the technical part and also with the financial part. For example, in this case, normally the installation time of networks with multi-tube cables is delayed because the cables are heavy, difficult to transport, and require crews of between 4 and 5 people to make the cable laying. Additionally, you have to specialize personnel and tools that are required to make splice. For example, in this case, you need crews of 3 people or more. So this special labor, it has a high cost for the FTTH project. Other important point is about the maintenance. So the question is, how long do you need to do maintenance on a fusion network? I think with you, for example, in this case, when you have a cut of the cable, you have um, to uninstall the perform hardware, recover all the cable reserve, install a new splice box. Also, you have to make the splices. You take a lot of time with this process. I think that at least when you have a CUDA cable, you will need around 3, 4, or 6 hours for repairing the network. So here, when you have a lot of time for the maintenance, I think that is very difficult for the users, for the end user, but because they all wants to be connected. It's so different when the EasyStart solution. Instead, with the EasyStart solution, you have products that allow you, for example, first point, easy to transport, which reduce logistics costs. You don't need a big truck, for example, for transport the cables to the old places. Second, easy to install with reduced implementation times. It's very important the implementation time because it reduces costs. 3, use a simple, compact, and cheaper hardware. It's so different because in this case, the traditional preformed hardware is made of steel for aluminum. In this case, you have to change. It's a hardware, it's a plastic hardware, it's compact, it's small, and of course, it's cheaper than traditional hardware for environment, for a hardware environment. 4, reliable because there are all factory tests with ensure compliance with the optical budget. 5, it's a solution, it's a plug and play solution that will reduce human error. It's very important because all the products are tested in the case inside Furukawa, so you have the guarantee that all cables and all boxes are okay for the project. And finally, all the boxes are IP68 protection. It's very important because you can install in aerial environment or in underground environment. Here we have comparison of traditional performing hardware versus compact hardware. It can be seen that the visual impact is also reduced. For example, in this case, we have a traditional preformed hardware for a DCS cable. It's like, I don't know, 1 meter of, in this case. But when you use compact preformed hardware, is very small. The footprint is smaller than the traditional hardware. So it's very important because in these cases, you can install faster the products in the area environment. So in summary, we can conclude that the main benefits of the EasyStart solution are many. For example, you can reduce the splicing of the network up to 94%, reduction of up to 40% of labor, of cost of labor. And you can reduce up to 50% of the total installation, the total installation time for all the network. Also, we have high availability. You can reduce the time, the time for the maintenance. You can have up to 20% of the reduction in the OPEX and reduction of 15% in total CapEx of the project. Of course, because all benefits we can have here, because all solution is plug and play solution. Other point is that the 63% reduction in the cable laying services, because we can eliminate all the traditional retention hardware in the distribution network. It's a lot of money that you can save using new compact plastic hardware. Okay. Now this is a study that Furukawa done for some customers. From the financial point of view, you can get reduction of 60% of the total capex, and you can have up to 25% or faster return of investment. It's very important, the return of investment, because you can have a better cash flow in your project. This is a real example with the ISP operator in the Brazilian market. Now we have here a real installation cases in Brazil, for an operator in Brazil. Let me show you how is the process. So we have here, in this case, for the laying services, only 2 people. This guy and the other guy is here on the pole. Only 2 people in this case. When you do with the same level with the traditional network, you have a crews of almost of least 4 or 6 people. Okay. In this case, we have a guy in the pole. He's activating the NAP. We only have to clean the connector and then connect the cable to the box. No more. You don't need to do any more. It's just a plug and play solution. It's very simple. The installing of the network, for installing the network. So in the superior, in the up part of the network, you have the main cable, the distribution cable, and in the below part, you have the drop connections to the customers. Perfect. Let's continue. So let's talk about the products. In this case, I'm not going to go into a lot of the technical details of the products, but it's interesting to mention some of the main points. So we have here CTOP. This is the principal distribution box. It supports up to 96 fusion splices. You can install on pole, wall, or messenger installation. Also, we have one main input for mini-span access. Also, we have 4 outputs for derivations. And finally, 16 precon outs for all the customers, for attending the users. Also, we have here the NAP, the network access point. This is the terminal box. This terminal box is connected to the principal, to the main box here. So the idea with the product is that the NAP is sealed. It's a sealed enclosure. This is very small. It's easy to install. You can also install on pole, wall, or messenger. And we have here up to 8 access to the subscribers. Here we have some photos that illustrate the example that I'm talking for you. In the parts of the cables, we have here the ADDS compact cable. ADDS compact cable. It's only 3 millimeters of diameter. It's very small. So the full spring is very small, and the cable is fully dielectric. Other important point is the cable has a high resistance to abrasion because the external coating is made of polyurethane. It's a material that is used in the military environments. So the cable is very resistant. And also the cable has inside a new kind of fiber optic cable, single mode cable, BLI, Bend Loss Insensitive cables. This is a standard of E2 657B3 fiber. So the fiber supports a lot of or reduced diameter for the installations. In the other part, we have here Joe Figure 8 low friction cable. The cover is made of lowest mode zero loading. It has inside BLI fiber 658 H2 fiber optic. And also the cable has a reduced coefficient of friction. And also you can buy in different colors, for example, gray color or black color. The gray color is very good for the new installations because the visual impact reduced inside the homes of the users. Furukawa, in addition to manufacturing products, offers excellent added value as a business partner for our clients. We have support in this case. We have a support and training team with no additional costs where we can help you in the process, for example, for training all the installation technicians, design engineering training, supporting the first projects, supervision is the first installations, and also certification is FTTS projects. And all these add value without any cost. Is a good idea. This is a real example with some courses that we made it for some customer in Mexico. And finally, why is STAR? So the answer is very simple, because it's an efficient solution that maximizes results. In addition to that, Furukawa supports you with logistics and local manufacturing. It's an important point of our added value because we can respond, we can help you with good logistics and with local manufacturing in a lot of countries around the world. We have many factories in all continents. Finally, let me show you some case of success. This is a real case in the Brazilian ISP market. This is a project in the new condominium, and the condominium in this case has a lot of users, but the ISP doesn't have all the money for deploy in the initial moment for all the case. So we can here is a real this is the general manager of the company. They had to reduce the investment as low as possible because they don't have all the money for the project. So the idea for this guy is only connect or only build the network only for the specific users that buy the services of the company. For example, the internet services of the television services. This project was awarded in the Furukawa last event, Furukawa Summit. So the solution it was very good for this company, the Condominios Esmeralda in Brazil. We have here the real examples when the technician installed all the products in the networks. The solution serves for this company because the cash flow, the solution helps them for the cash flow of all the network. This is a public video, is inside in our site, the Furukawa site. And also we have here this video in YouTube. It's free for watching. If you wanna the video to complete to watch the complete video, feel free to research. Okay. Perfect. So we come to the end of the presentation. Here in this section, we are going to solve some question of, of, of this solution. I would like to pass the word to Alexandre for this part, okay? Alexandre, go ahead, please.
Thank you, Leandro, for the presentation. So we still have some minutes to answer a few questions. So if you have any questions, please send them on the comment section. We already have a question from Luis. How do you connect the NAP to the distribution box?
Okay, perfect. Thank you very much for the question. I would like to show the graph, okay? Give me a second. Here, okay. In this case, when you have the principal box here, the principal box, you have to install the preconnect the precon distribution cable between the NAP and the principal point. Remember that the principal point and the NAP has a connectors here inside. It's a link connector, and here we can connect the distribution cable is pre-connect at both ends of the cable. So one end is gonna be inside the box, the principal box, and the other one is gonna be put inside the NAP. So this cable is like a outside plant patch cord, an optical patch cord for outside plant environment. Is clear for you, or do you have another question?
Thank you, Leandro. We have one more question, which is, what are the advantages of this solution for the maintenance in the network?
So really, we didn't have disadvantage. We have advantages when the maintains part, because, for example, uh, if you have, you imagine that we have a cut of the cable here in this part. When you have pre-con solutions, it's very simple the maintenance and the operation, because you don't have to do any splice here. You only have to replace the distribution cable. You only have to uninstall the cut cable, and then you're going to install another one new cable, connect here from this point and connect the other end here, and no more. So you have a considerably reduced time for the operation and maintenance. So it's a great advantages of the network, because the reaction time for reparation is very high.
Thank you, Leandro. We still have one more question. Time for one more question. Intan asked, is it possible to expand the network, the existing network, using this solution?
Oh, yes, of course, you can expand. For example, imagine that you have an existing FTTS network, a Precon or a traditional one, it's the same. When you have, for example, here, 8 access for a 10 subscribers, and you have here another subscriber near to the zone, you only have to put another one NAP, another distribution cable to connect it, and no more. You only illuminate the NAP, install the products, and no more. You can expand the network in the concept of the pace as you grow. Of course, it's applied for existing network or for a new network, for existing FTTS projects or for new FTTS projects. So the solution is very has very flexibility for expand.
Okay, thank you, Leandro. Other questions can also be sent directly to Leandro's email. which is at the end of this presentation. Later, you'll receive a link to its recorded video of the webinar that will stay available for you to watch again as you please. Also, please make sure to answer our survey about this webinar, as it will help us improve the presentations for the next sessions. We thank you very much for participating in this webinar, and we hope to see you again on the next ones. See you soon.